Welcome to this video on the topic of logical thinking. In this video, I'm going to show you how you can verify the behavior of a program using something called a desk check. A desk check being a tool we can use to ensure that our programs are behaving in the way that we intend them to. Now, the way in which I'm going to show you how this works is I'm going to use this program seen over here as a reference, and then I'm going to apply a desk check to it. Now, the program itself is a simple counting program. That being, it's going to start at 0 and it's going to output all of the integer numbers or the whole numbers up to the user specified number here. We call it top. Alright, now to begin running the desk check on this program over here, what we first need to do is we need to change it from its code equivalent to its picture equivalent, or we need to change it from pseudocode into its activity diagram. I've already gone ahead and I've converted the pseudocode here into the activity diagram equivalent as seen over here. Now the next step is to apply a desk check. We need to draw up a table. The table itself is going to have a number of columns that always exist in any given desk check. On top of that, it's going to have 2 additional columns. I'll explain why later. Now to begin with our table itself, the first column we're going to call it step. What step is going to refer to is the current stage that we're executing in our program. So what we're going to do is we're going to start at, say, step 1, and every time we execute a block of code we're going to go upwards by 1. So it'll be step 1, step 2, step 3, step 4, step 5, step 6, step 7, step 8, step 9, and so on. Now the next one across in our columns is we're going to call it block. Block refers to the current block in our activity diagram that we're running. Now, to be able to reference the blocks in our activity diagram, we have to enumerate them, or we have to give them a unique number. So I'm going to start from 1 and count upwards, so step or block 1, block 2, block 3, block 4, and finally block 5. It's important to remember that each of these blocks in the activity diagram have to have a unique number. If you want to skip numbers for some odd reason, so say for example if you wanted to skip 5, you can do that. So long as each block has a unique number, we're in the clear. I'll put that back to 5. Alright, now the next 3 columns across are going to be input, output, and finally result. Now input and output refer to information that is entering the program and information that is leaving the program. So think about it as, say for example, input. Input refers to information that goes from the outside world inside the program, and output refers to information that's currently inside the program that moves to the outside world. So say for example, if you're putting a number to the screen, then that's going to be a type of output. Now moving across, we have result. Result is going to refer to the result of when we ask a question. Again, I'll explain what this means when we get up to block 5 in our code over here. Now the final 2 columns we have over here are going to refer to the variables. Now if we go up and look at the code, because it's simpler to look at the code here, you can see that there's a variable top and there's a variable count. These also exist in the activity diagram here and here. Both of these variables are going to get their own columns. Alright, so we've managed to set up our activity diagram table. What we're now going to do is we're going to start tracing over the activity diagram here as if we were running the program, and as we're doing it, we're going to record the results of each block inside this table over here. What this will reveal by the end of the execution of the program is the exact behavior of what happened when the program was running. This is going to be useful in that if there are any errors in the execution of the program, we'll be able to discover where the error is and hopefully fix it. Okay, so starting off, we're going to start at step 1 and we're going to execute block 1. So this guy seen over here. The input into the program is going to have a value for this first case. So because the block itself says get top as integer, what that is inferring is ask the user for some information, or ask the user for a whole number. Now say for example we can input, perhaps could be anything above 0. We'll put in 5 just so the desk check isn't too long. Now, looking across, it says output. We ask ourselves, is any information leaving the program? For get top as integer, the result is no, there's nothing leaving. So what I'm going to do is I'm going to draw a dash. The dash itself represents that there's nothing there. Going across for result, I'm going to put a dash as well. I'll explain what result means when we get to block 5 down here. Now moving across, we see our variables top and can. Now for the first instance, it says get top as integer, or get top as a whole number. The input to the program was 5. As a result, 5 is going to get placed in top. Regarding can itself doesn't have a value, so at which point we're going to put a dash. Once again, this symbolizes that there's no information inside of can. It's not 0, it's nothing. Alright, step 2, we move down to block 2. Block 2 is set count to 0, so there's no input, there's no output, there's no result. The value of top is unchanged, and the value of count is now 0. Going down, we have print count. So what we've got is we've got block 3, step 3. Going into the program, we have nothing, but going out of the program, what this print instruction does is it's going to print a number to the screen. So what it's going to do is it's going to print the number inside of count over here. So we're going to go 0. The result, there's no question, so it's going to remain blank, and the values of top and count are unchanged. So I just put these marks over here. Going across, we have step 4. We are now at block 4. In block 4, we are add 1 to can. So there's neither input, nor output, nor result. The value of top is unchanged, but the value of count has gone from 0 to 1. Alright, now step 5, block 5. In block 5, we're asking a question. We say if count is less than top, do this. Otherwise, if count is less than top, or is not less than top, do this. So looking at this, our value for count is 1, and our value for top is 5. As a result, we're going to go down the yes path over here. So we're at step 5, block 5. There's no input, there's no output. However, the result, because count is less than top, it's going to reveal a result of yes, or in computer terms, we like saying true. The value of top and count is unchanged. Okay, so now we've gone from being down there to being up here. So what that means is step 6, we're now executing line 3 or block 3. In block 3, we're printing the value of count to the screen, so there's neither input, however the output, there's no decision, and the value of top is unchanged, value of count is unchanged. Step 7, we're doing this block here. Block 4, we are adding 1 to count, so input, no output, no result. Top is unchanged, but count has gone from 1 to now 2. Step 8, block 5. We ask the question, is count less than top? So is 2 less than top? The answer is yes, so we're going to write true. And these values are unchanged. There's neither input nor output. As a result, we're going to go to step 9 and back to block 3. Now what you can tell is it's quite repetitive what we're doing here. What I'm going to do to save a bit of time is I'm going to speed through to the conditions where things are going to occur differently. Alright, coming back, we're at step 16, which is block 4. What's just occurred is the value of count has ticked from 4 over to 5. Now we're about to run the question for step 17, block 5, which is count less than top? Now, the value of top is 5, and the value of count is 5 over here. So the issue we're going to have is because 5 is not less than 5, then we're not going to get a true condition occurring. So what's going to happen is we're going to get the no condition, or we're going to get the false condition. As a result, we're not going to go back upwards to block 3, but rather we're going to go downwards to the no condition here, which is terminate program. Consequently, what we're going to do is we're going to finish running the program itself. So terminating the program, what I've done is I've gone to the table and I've drawn this line underneath to show that it's done. I'm then going to write finished. So what we've got inside this table here is all the information that demonstrates what's going on when this program runs. Now this is a really useful diagnostic in that it's going to reveal to us whether the program is functioning as we intended it to. Now looking at this, the output, I'm going to look at this output column here and I'm going to write down the sequence of numbers. So we're going to say output, and the first output was 0, 1, 2, 3, 4. Now given that our input for this was 5, what we're expecting to happen was we're expecting the program to count up to 5. So if you look at the original definition here, it says output 0, 1, 2, 3, 4, 5, then top. So it should have printed the value 5. So what we can see by looking at this program here is that although it looks like it's mostly running right, the actual function of the program isn't what is described up here. So the program should have printed the number 5, and change printed to output it, should have output the number 5. So what we've got is the program not running correctly. So what this has demonstrated is that desk check is a useful tool to be able to explore the behavior of a program or observe the behavior of the program and subsequently debug or find any issues within the program. Now since we've found the bug that it should have outputted 5, what we need to do now is we need to fix it. So what we can see is that the issue of the program is this condition over here of executing, it should have done a true over here. So what we can do is we can have a look at block 5 and what we're doing here. So it says if count is less than top. Well, we still want it to execute if it's also equal to. So what we can say is if count is less than or equal to top. And what you're going to find is that by implementing this change to the code here, the false itself is going to turn true here. Then in the next iteration, count is going to turn 5, and then because count will be greater than top, then it will stop running. So that will give us the functionality. But in conclusion, what we set out to do in this video was we wanted to have a look at how we could apply a desk check to a program. This was achieved by firstly changing the program from its pseudocode into its activity diagram, and then by applying this desk check and putting the results inside the table shown over here.